So we've got our description below, just like before, right? So we've got our Santa sleigh here. We've got a 200 kilogram sleigh. They said that the reindeer are pulling with a 10,000 Newton force. And he's on the ground still, so he does have a normal force, right? And a weight and all that kind of stuff. And they said coefficient of friction was 0.01. And there's no units on that, right? So I want to know what our acceleration was in this case. So anytime I'm solving for an acceleration, we are going to think Newton's second law when we're dealing with force stuff. So that's net force divided by mass. That's an M. You cannot see that on the screen. Net force divided by mass is acceleration. I already know my mass is 200 kilograms. So I just need my net force. So that's my applied force. If there was no friction, it would just be 10,000 divided by 200, right? Since there's friction, we need to subtract that friction off, right? So I'm going to draw right through my reindeer here. We have a 10,000 Newton force that the reindeer are applying. We have weight of old Santa Claus and stuff, and that would be 2,000 Newtons. And so then the normal force is 2,000 Newtons. So I need to know how much my frictional force is. The equation for frictional force is mu times normal force. So that's going to be 0.01 times 2,000. So 0.01 times 2,000, you just move 2 decimal points, so that's going to be 20 newtons. So not much, right? Not much frictional force, but this is like Teflon, right? This is a magic sleigh, right? There's very, very little friction here. So all I have to do to get my net force is just 10,000 minus 20, right? So I would just take my 9,980 divided by 200 kilograms, and that gives us an acceleration of 49.9 meters per second squared. A lot. So basically 5 Gs. Right, so Santa Claus is experiencing 5 Gs of acceleration here, and that's probably not near enough to get to every house, but he's gonna have to make some good time there. Right? Hopefully that's you can't even see my face there. Hopefully that's helpful.